In this session, I'm going to talk about comparing the groups, two or more groups of data, one through tables, and then we'll also have some kind of quick visualizations of the same. So these are the main points in this session that we are going to look at. Find the descriptives by groups. Right. Earlier also we have discussed about aggregate as a command, which would typically do the descriptives group wise. So similar kind of things we are going to stress upon. Then we are talking about the visualizations per group, where I would be visualizing the frequencies or I might be visualizing the proportions of data. So which means these are all categorical kind of data which I would like to visualize. And similar kind of visualizations, I want to do it on continuous data like income levels, etc. So this is what we are going to look at here. Getting started, the main intention of this session is I would like to compare one group of data with respect to other, right? Males data versus females data. I want to compare some data across the groups and see if there is a presence of some kind of effect in the data. So is gender playing a role in terms of purchasing a particular product? So that is what I'm trying to address as a part of this particular session. And in the area of marketing, it's very, very important because it primarily helps us to understand the market. Which segment buys which kind of products? How much purchase is typically made by what kind of customers? So I can target my customers very, very effectively. And in case I'm doing some kind of marketing activity, like some kind of promotion, some kind of advertisements, I can evaluate the outcome quite comfortably when I'm doing this kind of comparison across the group. Without promotion sales versus with promotion sales, I can very well do a kind of a comparison activity. Then, so for that, what I could look at is I'll take a simple data set. Let me load that into R and simple questions like this. Right, the different kinds of measures, let's say household income, gender, vary for different segments. I want to do and analyze that. Right, is household income different across the different segments of population? Is gender really a differentiator across the segments? So some of the things that I can quite comfortably execute on the data. So what I'll do is I'll simply load the data first, right? A simple data I would load, and based on that we will try to see what all we can compute on the top of it. Right? Okay, let me get that data into R. So I'll call it as customer underscore segment. So let me load the data. It's a CSV file. Right, it's present in my H drive. It's okay, let me load it. So this is my data file, right? So I have loaded my data file out here. So if I just look at the dim of it, right, which says how many rows, how many columns that are present in it, I could see it's a data file containing 300 rows and 7 columns, and I can quickly check the head of it. Head of it to get the initial few records. So this is the data that is containing different segments of customers based on age, gender, income levels, number of kids they have, whether they own a home or not, whether they have subscribed to a particular product or not, and the segment of the customers. So I have some such kind of stuff. If I want something more details, I can take a summary of the same, right, where it will give me something more. Okay, regarding the age, The minimum age is 19, the first quartile is 33, median is 39, and so on. Gender, because it is a categorical variable, I have 157 females and 143 males in that values. Then income wise, this is the kind of a distribution I'm seeing. I don't know what is minus 5,000, but yeah, that's the kind of distributed income that I'm seeing. Kids, there are 0 kids. Minimum, maximum is 7 kids. There are 159 homeowners. 159 people don't own any home, whereas 141 people own a home. Regarding the subscription to a service, 260 of them have not subscribed, whereas 40 of them have subscribed. And segment wise, we have 4 kinds of segments: moving up segment, suburban mix segment, travelers, and urban hip, constituting the 50. So let this be the kind of a data that we want to talk of. Right now, let's say I want to find. So now let me take some subsections here. Group wise, I want to take some descriptives. So initially I can do an indexing part. So let's say for this example, I want to find what is the average income of males, right? Or I want to find the average age of the travelers group, some such kind of stuff. So if that is the case, I want, first of all, I can do an indexing. Indexing means directly match the values to a particular thing, and based on that, so if I say here, first of all, what is the criteria? I want to match it to males. So I'll say customer underscore segment, and out of that, customer underscore segment is a and dollar, because I am accessing gender out of it, equal to male, right? So this is, I'm simply checking where all the customer segment gender is equal to male. Now for those kind of people, I want to get, what is that I want to get? I want to get the income for them. So I'll say customer underscore segment dollar income. So this becomes a subset. So I'm taking customer segment income, and out of that I'm putting a rule. So which means I'm taking a subset of that income, right? I'm not taking all the incomes. I'm taking a subset of the income where the gender is matching to male. And on the top of it, probably I can think of computing a mean. So for whatever the data I have got, on the top of it, I can compute the mean. So this says the mean income of the males is 48,824. Similarly, instead of male, if the same I type it as female, it works out to 52,859. So at the on the verge of it, I can simply say that the females have a slightly higher average income compared to males. So that's how I can do an indexing part. Let's say if I want to use 2 rules also, right? Probably saying males and in the travelers segment, right? I want to say are males and homeowners. Male homeowners, what is the mean income? So what is that I can do? I can again repeat the same. So I'm saying gender is equal to male, right? In the kind of subset that I'm putting, I'm setting gender equal to male, And is the condition I can simply put, and I can simply say customer underscore segment dollar own home is equal to own S. So I'm simply saying, so for those people who are males and have their own home, I want to find out what is the mean income levels for that particular segment. So this says it's around 54,169, and for those people who don't have their own home, the same males who don't have their own home, I could see that their average income is around 44,371. So such a way you can very well bring out the segment, you can take out the groups. So I can match the rows, I can find the rows that match a particular criteria. That is how I have matched. So I have matched all the rows where gender is male as well as own home equal to S, and then take the mean or any statistic for the matching observation. So I am taking the income details for those kind of people, and on the top of that I have computed the mean value for those people. So you can combine it with and or also. So either of the ways. So this is one way, especially if I have to pull out some subset of observations. I can use using the row matching or indexing kind of a concept, and based on that I can pull out those particular rows and I can very well execute all my commands on the top of it. Then on the similar lines we have aggregate formula, which is also doing a similar kind of a work for us, but it can give us a data frame. We have talked about it earlier. So the same thing, if I want to find out for each of the gender, right, here the advantage is I can get for the whole thing at a stretch, right. So let's say I want the aggregate of customer underscore segment dollar income. I want to take the aggregate with respect to the income. I want to compute the mean income across all genders. So I'll put a list, whatever is the gender, I'll put it as a part of the list, customer underscore segment dollar gender, means I am typically and I say function is mean. So when I put this, I am trying to get the mean income of based on gender, the average income of the customers based on gender, means it will compute average income of the males as well as average income of the female. So directly I will get females average income is 52,000, the males average income is 48,000. Similarly, if I do this, let's say based on segment, do I have any kind of differentiation based on the customer segment? Is there any difference in the average income? So it says travelers generally have a very high average income, whereas the urban hip is having a very low average income. And the advantage of this kind of scenario aggregate function is this is a data frame. I can even assign it to something, right? And I can very well pull out those particular values that I typically want. So that's a kind of an advantage that we can work out when we are using the aggregate. The result is a data frame. So aggregate, actually it is exemplifying the power of R, where I can extract and manipulate the data with simple commands. Because now the aggregate is there with me, I can do anything I want on the top of the aggregate. right? I can very well pull out any of the values with respect to the aggregate. It can allow us to compute functions for any combination of factors. So I can do some kind of a function. I don't need not just a mean here. I can do standard deviation. I can write my own custom function. I can do any kind of function on the continuous variables for any combination of the factor variables also. It just need not be one variable. Now you could see I want the segment as well as gender. I'll put both of them as a part of the list. Customer underscore segment dollar gender. I'll put that as a part of my list. So suddenly I get two groups. Moving up females, this is the average. Suburban females, this is the average. Traveler females, this is the average. So I get all kinds of, and even moving up male, suburban, mixed female. So I get even two groups coming up. So any number of groups I can very well create quite comfortably using the aggregate function. So even if I can bring in multiple variables grouped up also, it becomes quite comfortable to execute. That's the kind of an advantage the aggregate is bringing in. Now in the aggregate, a slightly different way of defining also, right now whatever the way we have defined the aggregate is, within the aggregate I have used the continuous variable which we want to compute. Then we have used the grouping variable or list of grouping variables, and then we have used the function. So this is what is the typical way we have given the aggregate. But right now I want to introduce a slightly different way of giving an input to the aggregate. This is what is a tilde operator, especially when I want to describe the relationship among the various variables, right? I can very well use this tilde operator. So I'll give a response variable, which is what I really want to find out. That would be there on the left, and I have the explanatory variables on the right. So in the same case, let's say I want to find the income across gender. I write it like this. Or let's say income across the segments as well as gender. I separate it with a plus sign. So I can do this kind of a formula kind of a way also as an input into the aggregate. So this is a very interesting, if I'm putting it into the aggregate, so I'm trying to aggregate y across the levels of x. So I can define a formula, I can define my data, and I can define my function. This is another way of using aggregate, right, where I can define the formula as a relationship between x and y, define the data as well as the function part. So let me try the same here. I'll say aggregate. The function is income. Let's say I want it based on segment, right? Income based on segment. I'll say data equal to customer segment is the name of the data, and function I'll take it as mean. Okay, segment should be a capital S, right? So I'm getting it as I'm getting the average again in this manner when I have used the tilde operator as well. So I can very well increase even both of them. Let's say the same thing, customer segment plus gender. Sorry, this is not, I want to do it as segment. Along with the segment, I want gender. Now similar kind of a table that we have got here, we are getting here as well. But this is a slightly different way of giving the different variables as input. Right, I can very well add any number. So even if I can add own home also, one more variable, right? If I want to add one more variable, own home. So then all the particular segments, so segment, gender, own home, what is the income for it? So in that all combinations will be taken and everything will be aggregated and represented for us, right? And in this, because this is a data frame, I can very well get a subset of this as well. Whatever is the aggregate that I am getting, let's say I want only the second row of it. It's a straightforward thing. I'll get only the second row for it. Because this is a data frame, I can even access a subset of this as well, right? Then, in some cases, yeah, this is what I have already discussed. Descriptives for two-way groups, right? I can very well say x1, x2, all of them joined with a plus operator. So I can specify multiple explanatory variables. This is what we have seen just now. The formula can be extended to include as many grouping variables as required. That's the kind. So we have already used 3 also as a part of our example. So the formula can quite comfortably be extended. Then the next formula that I'm going to look at is the table. Table is something that's going to work when I am more interested in computing the frequencies, right? Especially when I wanted more and more of counting of the data, I want a table. So here I can use the table, right? So I can simply say table customer underscore segment dollar segment. So the table will do the counting part. So this is saying, yes, there are 70 people in the moving up, 100 people in suburban mix, 80 in travelers, 50 in urban hip. That's a count. Now on the same, on the top of it, let's say I want to add one more. I want the two-way table. So for each of these guys, how many of them are males and how many of them are females? So I can simply add customer underscore segment dollar gender. So it says, yes, moving up, there are 49 females, 21 males. Suburban mix, there are 48 females, 52 males, and so on. This is the kind of a breakup. Now, what if I add the third one? Customer underscore segment dollar own home. I want to break it even more further. This is where it gets translated into it's a three-dimensional stuff. So it will compute something like this. For own house is equal to no, it creates one table. For own house equal to S, it creates another table. This is the way it represents, even if I am giving the third input, fourth input kind of stuff also into my data. And so we can very well add up the stuff. We can very well count up the stuff using these kind of scenarios. So what we could see is, for in many cases, slowly we'll come to know, for arriving at a particular kind of an output, R has so many ways of getting to that result, right? Especially if you see aggregate as a function, I could have used to get a result. Similarly, in some cases I have said indexing is also a method to get the result. And in one of our previous sessions, I have even used the function by to get the result. These are all aggregations across the groups itself, which means R has different ways to arrive at a particular result. Each result, if you see each method, the result is produced in a different format. So which means not all can be used in all scenarios. In some scenarios, the result that is produced in some specific format could be much better compared to some other scenario. Now this is where we have to be very much judicious in terms of seeing when to engage what kind of method. So the other way I can look at this similar advantage is because there are multiple ways of doing the same thing, I can very well do it in two of them and probably use them for comparison purposes. Right? I can validate my responses quite comfortably because I have done it using two different mechanisms. So that is what about finding the descriptives by group. Then I am moving towards creating some kind of visualizations by group, wherein my focus is on frequencies as well as proportions, which means here my focus is on categorical data, which is otherwise treated as factor in R. So this is primarily on the factor variables, right? So there are again different ways of doing visualizing the data. So this is where I want to use the lattice package. Some features, quick things available as a part of the lattice package as a solution. Though I can very well, let's say here I want to find out, right? I want to find out the gender across the different travel segments. So first thing I could have created is I can take a table, right? That in the table I am taking customer underscore segment dollar segment, different segments of the customer, and I am also taking the gender, customer underscore segment dollar gender. So my table will be created in this way. Now what is that I can do on the top of this table? I could simply come out with a bar plot, and either I can save this table as a variable and create a bar plot on the top of it, or I can pull something like this. So it's giving me a kind of a quick bar plot, right? These are the females across the segments. So these are the four segments, these are the females, and this is the kind of a distribution of the male. So this is how this graph is going to give me, and all other things like legends, etc. The headers, the legends, everything had to be taken care of by me. But at the same time, let me use a lattice package, right? So we have to first install that package. It's already installed on my system, so that's where I'm simply loading the lattice package. Loading is done through the library command. So the lattice package is simply is directly used. Now I'll use the histogram function. So histogram is an interesting package, right, wherein I am giving formula. The formula is, right, y versus x with a tilde operator. It takes the data on which I am creating, and it even takes the type. The type, where we will talk about the type. So this is what is quite commonly used, right? Here the advantage is it can even understand the formula notation, which our regular base R does not understand, and it can also help me in doing conditioning on a factor. This is a very big advantage associated with very big advantage associated with the lattice as a package. So if we just see the same, for let's say for 4 types of segments, I want 4 kinds of graphs. So I'll say histogram, it's a command I'm using. The formula that I put, okay, here histogram is simply doing the counting here. So I don't have any kind of a variable y here. I'll directly put a tilde operator and I'll say gender. So wherein I'll get the breakup of the gender. But let's say I want it segment wise. Then I'll use it as a conditioning operator. With this R symbol, if I put segment, what it means is it will try to plot the genders segment wise. So it will take the traveler segment, plot what is the mix of the gender. It will take the segment 2, right, plot what is the mix of the gender, and so on. So in this, the data that I am providing is simply the customer underscore segment. That's the name of my data frame. So with this, if you see, it's a completely different graph that I am getting. This is the travelers. So because I have done the segmentation, I have done this what you call breakup, right? Conditioning based on segment. So I am getting 4 different graphs, one for each segment. And in each graph, I am getting a mix of males and females. Probably look at the look and feel of this graph is much more sophisticated compared to the traditional graph that we have got on the typical R package. So few things that I need to remember in this histogram formula. I don't need any response variable before the tilde because it automatically understands that it has to do the counting of the explanatory variable. So if I just provide the explanatory variable to it, it is quite sufficient. So it is assuming that we are more interested in plotting the proportions at each of the levels, the mix of both, right? The mix is something that it is trying to look at, that we are more interested in getting the mix of males versus the females. So as a default, it is plotting the proportion. You could see here, right? It has taken 0, 20, 40, 60, which is the proportion. So approximately 60% is male in urban hip and around 40% constitute the female. Whereas in case of moving up, I think females are more than 60%, males are less than 40%. So I could see that the what it is computing typically is in terms of proportions by default. So it is trying to give me the values are relative to the group size, right? Even if I do any other, let's say I want to go with each segment, right? Instead of looking at the gender, I want to know how many of them own homes. Yes versus no. So my graph has changed altogether. In terms of travelers, right, almost 80% of the population is owning a home, whereas hardly 20% of the people don't. Whereas in urban hip, it is exactly the reverse. 80% of the people do not own a home, whereas 20% of them own a home. Right? Similarly, if I look at the suburban mix, it's almost equal. So you'll get a good picture when we are plotting these kind of graphs in a much better manner. Whereas in some cases, I'm not interested in proportions. I'm actually interested in the actual values. I'm not more looking at the proportions. I'm looking at the actual values. In that case, I can simply set the same thing where type, that is what I'm putting as a type. In type, I can type in count. So when I'm putting type equal to count, instead of doing proportions, it is doing the actual counting and it is presenting to me. Now by default, it presents like this. But let's say I want all 4 of them one beside the other. Instead of 2 by 2 kind of stuff, I want 1 row, 4 columns kind of stuff. Even that is quite comfortably achieved by using a layout. So the same thing I will extend layout, wherein I am setting the layout as C4, 1. So first 4 in 1 row, and like that I require 1 such row. So suddenly I see all 4 of them are plotted next to each other. So this is the kind of an advantage the lattice package typically brings in. Or let's say I want color differentiation also along with the layout. Let's say I want one of it to be in green, the other one to be in red. I mean, you can very well choose better colors as well. So one I want it to be in green, the other I want it to be in red. So the graph gets quite comfortably improvised with all these things. So, and even you can very well add more and more kind of variables. Let's say I'm looking at what proportion of the people own their home segment wise. But along with the segment, I also want, let's say, gender also being added to it. Right? Not just the segment, I want the gender also added to it. I can simply do a plus. So even the conditioning I can do on more than one variable. So now you could see here males. So this is what is the scenario, because I have asked for layout as 4-1, only 4 of them are being shown. Probably I should ask it for 4-2 now. Right. This is the table I am getting. Male moving up. This is the numbers. Female moving up. These are the numbers. Now, this is how I can improvise my graph to any kind of details when I'm using this histogram package. Right? Quite comfortable. So, by default, it will do the proportion, but I can set it to count, wherein I'm doing the actual counts instead of proportions. I have different kinds of options to play around with the color. I can play around with the layout. I can do the conditioning on more than one factor as well. All these kinds of things improvise our visualization of the data per group. Then one more thing that I am typically looking at is the proportion. Right? In some cases, I may not be interested something like this, but I'm more interested in creating a table in the form of proportion. Right? So the data, it is like this here, but this data I want it in the form of proportion. So this is where, let's say I'm using the same table. Right? If I use this table, this is what is the table that is coming up. Now the same table, let's say I want it in the form of a proportions, column wise proportions separately. For this purpose, I'll use a function called prop.table. Prop.table is a function which I will create on the top of the table function. First I'll create a table. On the top of it I create prop.table, which is proportions table, wherein I'll have to set the margin. If I set margin equal to 2, it takes the column wise proportion. When I set margin equal to 2, it takes margin column wise proportions. If I set margin equal to 1, it will take row wise proportions. If I don't set anything as a margin, it will take the proportions with respect to entire table. So on the top of it, once I get that, probably I can very well again do bar plots or bar chart on the top of that data as well. So here I'll get the data directly in the form of proportion. So the data is also, so 31%, 30%, 25%, 12%, all put together becomes 100% here. So the data comes in terms of proportions of the column. If I set margin equal to 1, I'll get it in proportions of rows. 70% is female, 30% is male. So I have to really plan out in what form I want my data. So prop.table is also one more interesting function for us, right? Which typically computes the data, tabulates the data in terms of proportions rather than in terms of absolute count values or the numbers. Then, similarly, if I have continuous data, how do I do the visualizations? Even here for continuous data we have already done the aggregations using the aggregate function, and once the aggregating is typically done, I can use the bar chart from the lattice package. Right, I can use the bar chart from the lattice package once I get the aggregated result. So let me get again aggregate, right, or we have already used a lot of aggregate earlier. So if I want income versus segment, right, let me take aggregate income versus segment. So I'll take it as a formula. The data I will take it as cust underscore segment, and the function I am setting it as mean. Okay, so this is what is the aggregate that I have got. Now I can very well take the bar chart on the same thing, right? Probably if required, this itself can be saved, right? That's an advantage. So I can simply call this as segment underscore mean. I'll call this entire aggregated function as segment underscore mean. Now I can do a bar chart wherein I can very well take these two as inputs. So bar chart also takes the formula. So I'll say income tilde segment. So segment wise you plot the incomes, right? Segment wise you plot the income, where the data this time I'll take it as segment underscore mean. And probably if I want I can set the color, which I can set it as green. So a bar chart typically comes out, right? It is doing a plotting of income versus the segment. So probably I can very well make out that in this segment people have very less average incomes, whereas here it is much higher. So it's so even the data frame can be assigned to a variable. So it's another data frame. That's the advantage of a data frame. The data frame, any calculation, any aggregate that we are doing on the data frame is itself another data frame, right? You can very well take it to any layer, right? So probably if I am looking at the segment mean again, instead of just taking the segment alone, I'll also take it as, let's say, own home. So I'm taking both of them to aggregate. So now I have got the aggregated segment, right? So if you look at segment underscore mean now, this is the data that we have got, right? Income segment own home. So now the advantage is I can still plot the income, right? Let's say I'm talking about a bar chart. Still I'll use income tilde segment, right? I'll use income tilde segment, wherein the data I'm still considering is segment underscore mean. But now I'll talk about the grouping operator. So I can do a grouping based on the own home. Whether he has a own home or not, I'm talking about a grouping operator, right? So which means it will plot a separate group, right? It will segregate the groups based on whether the person is having a home or not. And here the advantage which we don't have in the typical base R is I can very well set the legend to be automatic, which is what I can set using the auto.key command as true. Auto.key argument, if I am giving it as true, the legend is automatically set. So first it is directly setting people who don't own a home is light blue color, who own a home is this kind of a color. Now that we are plotting income versus segment, so the income is plotted segment wise, but the grouping is done based on whether the persons own a home or not. So that way we can very well create these kind of charts quite comfortably in R. So I am able to group factors. The factor will become my grouping variable. This is how I have done it here. The factor is becoming my grouping variable, right? If I want to do the same by gender instead of owning a home, okay. Now I don't have gender as a part of my data, so I can't anyhow create that stuff. But yeah, if I want to change the graph a little bit, saying okay, I want segment wise separate groups, but I want it income versus own home. So now the graph changes slightly. For people who own a home, these are the ones across the four segments. For people who don't own a home, these are the average income levels across the segment. So we can play around with the data, and that graph can quite comfortably be converted into a bar chart without much of a difficulty. So if we are working with the continuous data, that's one more aspect that we can look at. Then more and more a better chart for a continuous data is a box and whisker plot. Compared to the bar charts, the box and whisker plot is much more an informative plot. Sometimes we simply call it as a box plot. Primarily I'll use it for comparisons, right? Especially to identify the outliers that are present in the data, because it shows more and more information regarding the distribution of the values. Are any of the values more concentrated outside the limits, or majority of the values are within the limit, or what it is? So more and more information compared to the averages, because it can even help me to identify the outliers also quite comfortably. So that's the reason we generally use the box plot as well, right? For the same data, I can even do a box plot, right? Let me take a box plot between income across genders. So I'll take income across gender. So I'm finding the income for males, income for females, where the data is coming out as cust underscore segment. That's the name of the data that I'm getting. And see, if I keep on adding the stuff, I can very well add, right? First, let me plot the base box plot. So it will do gender wise incomes. So this is the box plot for females, this is the box plot for males. Now I could see there are some kind of values that are coming on the y-axis. I am not interested in this axis. So when I am not interested, what is that I want to do? I'll simply set y-axis text YAXT. Y-axis text, I'll set it to no. The moment I do that, the text on the y-axis is typically going up. Then if I want some kind of label on the y-axis, I'll put ylab. Ylab is the label on the y-axis. So I'll set income levels. So I get a label on the y-axis. Now I want to set some kind of a sequence, right? So this is where I'm setting a sequence. So I know what is the minimum and the maximum levels for, right? So probably I want to know what are the minimum and the maximum levels of the income. So let's say I'll set it up to 10,000 or 12,000, sorry, 120,000 kind of stuff. So I can really set, I'll take a sequence, right? So I'll set an axis for this. First of all, I need a y-axis, so I'll set side equal to 2. Now, what is the sequence that I require? So I'll set what is the text, axis text. I'm setting it. wherein I'm calling it as a sequence. I'm taking it as a sequence from 0 to probably 120,000 and by let's say 20,000. So I'm incrementing it by 20,000. I'm creating a sequence from 0 to 20, sorry, not 200,000, 20,000. So I'm increasing it from 0 to 120,000, where I'm increasing it by 10,000. So this is the kind of sequencing I'm creating. And probably I want to create it not vertically but horizontally. So this is means I'm setting LAS equal to 1. LAS equal to 1 means the text would be shown in a horizontal direction rather than a vertical one. So I could get, this is the way the text would be displayed, 0, 20,000, 40,000 kind of stuff. And yes, if required, probably if this is looking too odd, probably I can reduce the font of it as well. So this is the kind of settings that I can do to the graph. The box plot is very interesting plot, which is from the base R itself. But a slightly better looking box plot again is from the lattice package, which is called as BW plot. And even it allows multi-factor conditioning. That's another. Conditioning is one interesting aspect that is a differentiator with respect to the lattice package. So I can use the formula, but the thing is here, I can't use the formula in the same way. It's not y tilde x, but it is x tilde y. That's the only thing we have to remember when we are using the BW plot package. Right, I have to give it as x tilde y kind of stuff. So let me just use that BW plot. So I want to find let's say gender wise income. So I'll call it gender wise income, but let's say I want to condition it based on segment. I want to condition it based on segment, so I can put it like this: data equal to cust underscore segment. So I can set this. So this is how I get different kinds of 4 different kinds of graphs, one for each segment. I'm getting a different box plot, which is slightly different from the corresponding the simpler chart that is coming from the base R. So the more and more I'm using the lattice package, there is a lot about this kind of visualization that I can do on the continuous data as well as on the discrete data, right? So this is what I wanted to offer as a part of this session. If you have any further queries, you can very well get back to me by giving me a call on the number that I have provided below, or you can send in an email at the email address that I have given there. Thanks a lot for listening to this session. Thank you very much.